This is our first lesson on saving and borrowing. In this lesson we're going to be looking at simple interest. Now, simple interest is calculated from an original amount. It's used to give you a rough estimate. This is only a simple and crude basic way of working out the things you need to find, and it'll calculate interest based on what you borrowed from the bank or how much you lent someone and charged interest from them. As a little side note, simple interest is also called flat rate interest, and the formula we're going to be using today is the one right there. I equals PRT. I is the interest, P is the principal. Now the principal also stands for the original amount you deposit, and R is the interest rate expressed as a decimal. So remember, when you have a percentage, you need to divide it by 100 to get it in decimal form, and T is the number of periods, or just time. Let's jump straight into our examples. We're going to be having a look at 4 different examples. The first one is just a simple substitution. The second one is a bit of additional information. The third one, we need to play around with our formula, and the fourth one is we need to rearrange. So here we are with our first example. Calculate the interest earned if Patrick deposits $8,000 into a bank account for 5 years at 6.2% per annum. So our formula is I equals P R N. I is the interest, which is what we're looking for. P is the original amount. R is the percentage, the interest rate, and N is the number of years. So there are our little separate bits of information. We're going to sub those right in. So P is 8,000 multiplied by the rate, which is 6.2%. We're going to divide it by 100 because we need it as a decimal, and then we're going to times it by the number of years, which is 5. All up, this is going to give us $2,480. Now remember, this is just the interest, so he still gets to keep the $8,000 he started with, but in addition to that, he's going to get another almost $2,500. Okay, in the next example, we need to calculate the total amount Patrick can withdraw after 5 years if he deposits the same amount for the same amount of time at the same rate. Now this one's a little different because it's asking for the total amount. So in the previous question, we just worked out the interest. In this question, we need to find out how much Patrick's going to have at the end of that. So if we use the I equals P R N formula, we know that that works out to be $2,480. So that's just subbing all those in. What we need to know now is that the amount is equal to the interest plus the original amount, or the principal value. So the interest was $2,480 plus our original amount we deposited of the $8,000. It's going to give us $10,480. Now what this means is when you deposit money into a bank account, you don't lose that money you originally put in there. You get to keep that plus any interest that you made. So Patrick gets to keep the $8,000 that he's deposited in there. He left it for 5 years, so it earned another $2,480. And then when it comes time to, at the end of those 5 years, withdraw the money, he gets the full $10,480. Okay, moving on with the next example, we have to match the time to the rate. Now, this is its own example because of the fact that when you're dealing with percentages and the number of years or whatever, they need to be in the same unit, otherwise our formula won't work. So our formula is I equals P R N. Now in this case, we're still looking for the interest, so it's still I equals. Our principal amount is still $8,000. We're going to be multiplying it by a 2.2% per quarter for 5 years. So it's 2.2 divided by 100, because we need it as a decimal, multiplied by 5. Here we have the interest rate being per quarter, but our time is per year. What we need to do is adjust one of those so it matches the other. Now, what I'm going to do is I'm going to leave the 5 in years, and I'm going to convert my percentage into per year instead of per quarter. Now, because there are 4 quarters in a year, I need to multiply my interest rate by 4. So instead of being 2.2% per 3 months, it's going to be 8.8% per year. So doing that on the next line, $8,000 multiplied by 8.8 divided by 100 multiplied by 5 will give me $3,520. And that's it. Just the interest is all we need this time. We don't need to add that on to the original amount because the question only asks for interest and not total amount. Now moving on to our last example, we have a rearrange equation. Not all the time we're going to be asked to calculate the interest, so we need to know how to work with our equation so that we can get what we need. So let's have a look at what we've got. Patrick has invested $4,000 into an account that had an interest rate of 4.3%. How many years would the investment take to earn $860 interest? So let's just label the bits that we have. Up here we've got our P, that's the amount we put in. Right here is the interest rate, and down here is the amount of interest he earned, which is I. Our formula being I equals P R N means that we're missing N, and that's what the question asked, how many years? So we knew that we were looking for the time. Let's go ahead and sub these values straight in. 860 equals 4,000 multiplied by the rate, which is 4.3% over 100, multiplied by, we don't know what the time is, so we're going to leave it as n. Now first off, we can do this side of the equation. We can multiply 4,000 by the 4.3 over 100, so we're going to go ahead and do that. Leaves us with 860 on this side and 172 over here, and that's still multiplied by n. Now we're going to have to get rid of this 172, put it on the other side of the equation. Because it's been multiplied by the m, we're going to have to divide by it. So we're going to be left with n equals 860 divided by 172, which is going to give us a total of 5 years. So Patrick needs to invest $4,000 for 5 years into this account before he can expect to receive $860 in interest. Okay, that's it for today's lesson. Thanks for watching the video and good luck.